We we often don't think about the infrastructure that prevents disasters
Yeah.
until, well, it's too late. Today we're doing a deep dive into something designed to catch failure on a tiny scale.
hmm
It's the NTI E-TLD-P10. It's a specialized tape-style liquid detector, the
Yeah.
kind of thing you'd find in really mission-critical
Yeah,
facilities.
and our mission here is to figure out why this is, a high reliability component and not just some simple sensor you'd buy at a hardware store.
Okay.
The sources immediately tell you a couple of things. One, it's TAA compliant, so it meets U.S. government procurement standards. Trusted supply chain,
It's a big deal.
huge deal. And two, it's not a standalone device. It needs power from a central hub, like an E2D or E5D unit. So it's part of let's say, an integrated critical ecosystem from the get-go.
That makes a lot of sense.
Yeah.
I mean, you're talking about protecting servers and data centers worth millions,
Mhm.
not just a leaky pipe in a basement.
Ex-
So let's get into the mechanics. How does this tape-style detector actually work? The source says it uses a self-adhesive tape with copper fiber electrodes.
Yeah, and that immediately raises a question, right? Copper.
Right.
Right.
Doesn't copper corrode,
Yeah.
especially in the kind of damp, hidden places this thing's designed to live?
Well, that's where the engineering comes in. The copper fibers are protected by this durable netted cover. And this is the key part. It's designed to detect conductive liquids.
Oh.
It's a really crucial distinction. It helps stop false alarms from, say, industrial oils or other non-conductive fluids. It's looking for water, which becomes conductive with even the tiniest amount of impurities.
And here's the part that really got me. The sensitivity. We're not talking about waiting for a puddle to form.
Not at all.
The source gives us a specific metric. It can detect a liquid presence of just 0.125 inches. That's 3 millimeters in diameter.
Just 3 millimeters. Think about that.
That's barely a drop. You're detecting moisture before it can even think about wicking up into a server rack.
Exactly. And that precision has to work over long distances and in tough environments. These things are weather resistant. They're meant to be put on floors, under pipes, tucked away in ducts.
Which brings up a really critical point about reliability. If you have 100 feet of this tape snaking through a facility, what happens if the tape itself gets damaged or cut?
That's the million-dollar question, isn't it? And this design has the answer. It's a feature called Continuous Tape Integrity Self-Check.
A self-check.
Yes. So before the tape can even tell you about a leak, it's constantly verifying that it is okay. It's like a pulse monitor for the sensor itself, making sure the guard is always on duty.
That's self-checking. That must add a lot of complexity to the engineering. And I think we see that in the price, right? The basic 10-foot unit is $575. But if you jump to the 100-foot option, the price goes up to $2,560.
Yeah, and that's the key insight here. It's over 4 times the price for 10 times the length.
So it's not just the cost of more tape.
Not even close. It's not a simple linear cost. It still runs on very low power, just 60 mA at 12 volts. But ensuring the signal is clean and that integrity check is reliable over 100 feet. You're dealing with impedance, with signal degradation.
So there must be more sophisticated electronics built into the longer cables themselves.
Absolutely. It has to be. That's what you're paying for.
So what does this all mean then? We've seen that this kind of high reliability monitoring comes down to these tiny but critical details. You've got the copper fibers, the 3 millimeter sensitivity.
And that all-important ability for the sensor to constantly check its own health.
Right.
And our final takeaway is really about that scaling challenge. If guaranteeing the integrity of 10 feet of tape is so much cheaper than guaranteeing 100 feet, you have to ask, what deeper technical hurdles are they overcoming to justify that cost? What kind of signal boosting or, other tech is embedded in those longer cables to fight the basic physics of signal loss? That's something to think about the next time you consider the hidden systems protecting our most valuable assets.